Bismillahirrahmanirrahim. Assalamualaikum and salam sejahtera. In this session, we want to discuss the direct time study example, which we focus on the third to fifth procedure from the observation time to normal time using the performance rating. From normal time, we compute the standard time using the allowance factor. Questions? A process at a wash assembly plant has been changed. The process is divided into three work elements. Yeah. So you can see in the table there are three work elements here, element 1 to 3. A time study has been performed with the following results. The time standard for process previously in the old method is 14.5 minutes per watch. In the new time study had an initial sample of 4 observations. So 4 observations here. The performance rating factor is shown for each element. So we know that we have to calculate specifically normal time for each element because the performance rating factor is given for each element. Yeah? And the allowance is 18%. So based on the new time study, this table, analyze whether the time standard should be revised compared to the previously standard time 14.5 minutes. Yeah. So we have to calculate the standard time for this example. So again, first we have to determine the average time for each element. Example in element 1, yeah, 2.6 plus 2.34 plus 3.12 plus 2.86 divided by 4. So the average observed time is 2.73 minutes and followed by element number 2 and element number 3. From average time, we determine the normal time. Again, because the performance rating given specifically for each element. So the normal time also have to determine specifically for each element. So from element 1 example, average time is 2.73 times by 1. So the normal time is 2.73. For element 2, 4.875 times 1.1. The normal time for element 2, 5.363. And followed by the normal time for element C, 1.922. And from here, we total the normal time for the task. The total normal time is 10.015 minutes. And from the total normal time, we calculate the standard time, yeah, using the allowance 18%. Yeah. So the standard time for this new method is 11.82 minutes per watch. 11.82 minutes per watch. So compare with the previous standard time, 14.5 minutes, it shows that the new method have a better standard time with the previous method. So in conclusion, we accept the changes on the method because the new standard time is improved compared to previous standard time. Okay, we move to the next example. Questions. A direct time study was taken on a manual work element using the snapback method. Again, previously we have learned in time recording we have two methods using snapback method and another method is using the continuous method. First snapback method, the second one go using the continuous method. So in these questions, the time observed using snapback method. Again, what we mean by snapback method? We can see that here in the observation time here. In snapback method, the time will reset back to 0 for each element. Yeah. So data here, yeah, example for element A, 1.56 here minutes is specific for A. 0.25 is specific for B. 0.5 minutes is specific for element C, and 1.1 minute is specific time for element D. t. Again, because in snapback method, the time is set back to 0 in each element. Okay. So the regular cycle consists of three elements A, B, and C. So A and B is regular element. Regular element means it appears in every cycle. But in element D is an irregular element that perform every 5 cycles. So for D, highlighted here, D is an irregular element. Means it's not appear in every cycle, but only appear in every 5 cycles. And given the allowance is 15%. Okay. So to solve it, we look at the next table. So for element A, B, and C, because it's a regular element, so we determine as usual. For example, in A, yeah, so 0.56 times by 1, normal time for B, and this is element time for C. But for element D, yeah, for element D, we have highlighted that element D is an irregular element that perform every 5 cycles. So in element D, we have to divide it by the number of cycles it appears. So in this case, this element D appear every 5 cycles, so we divide it by 5. Yeah, divided by 5. So from there, we determine the normal time. Yeah, from normal time, we calculate the standard time. Okay. So what we learn on this example 4, first, the time observed in this example taken using snapback method means the data in each element is already specific for each element. And A, B, and C is a regular element, so we calculate as usual the normal time. But in element D, it's an irregular element, so we have to divide it by the number of cycles the element perform. In this case, it perform every 5 cycles, so we divide it by 5. Yeah. Okay. So that's for this example. We look next example. The observed element times and performance rating collected in a direct time study are indicated in the table below using the continuous method. So in this example, the observed time using the second method, continuous method. Yeah. So in the previous example, using the snapback. Now in this example, using the continuous method. Yeah. So we can see the observed time in each element. Yeah. Because in continuous method, the time will not reset to 0. So what happened? Each element, the time will be continuous. So it become bigger and bigger. Yeah, from 32 to 63, 93 seconds, and continuous to 130 seconds. Yeah, means this time for each element is not specifically for each element because it's continuously. So how to determine specific time for each element? So we can look at the next table after this. And allowance is 14%. Yeah. Determine the standard time for the work. Okay. So again, this is continuous time for each element. So how to get this specific time for element B? Yeah, element B. So to get the time specific for element B, the continuous time at B must minus from time A, from previous time. So 63 seconds minus by 22, so we get this 41 seconds. So we do the same with the element C and also element D. Yeah. And then from here, we determine the normal time, and then we determine the standard time. So in this last example, we look at how continuous method been used and been solved. Yeah. So thank you.